Hi there, welcome back. I'm glad you've had a chance to take a look at that first tutorial. I'm hoping that we can build on that foundation here. This is the full-blown project, tower defense, very popular genre. And we're using those basic building block skills you learned in the introductory series to build a full-scale game more similar to what you might find on the Play Store or Google Play or tools and venues such as that. So I think you're going to find this is going to add some real more game features, if you will, to what we did in the introductory set. We're going to focus in this second tutorial on tank objects, and the objectives where the tanks are heading along a certain path. So without wasting too much more time, let's go ahead and dive in. I think it's always important to take a quick look at where we are in the overall build process. As we kind of walk through here in that first tutorial, to build the full tower defense game is going to take a total of 6 total builds. This is the second build where we're kind of adding tanks and objectives, as I said earlier, onto the foundation and the project setup from tutorial 1. As you see here in the overall game plan, when we finish this tutorial, the next one will add the towers, and then we'll have the fire exchange between towers and tanks, and then we're going to get into scoring, resources, and health, those types of issues. And then we'll get into some final extensions to add some real playability features to the overall game. So as we said earlier, the structure of these tutorials is to take a finished, completed project for build 2 and decompose that into each of the individual objects and components and the script files, so you can see how they're integrated and see all the various moving parts. So let's go ahead and proceed. I thought it'd be helpful before we actually start getting into the details, take a quick snippet of what's the end product of build 2 really going to look like. So as you can see here, I've just kind of taken a couple of screenshots. We're going to have a series of tanks moving along a designated path. There's going to be multiple paths in each of the scenarios. There's going to be a tread mark that's actually trailing behind each of the tanks to give it a better look and feel. There's an enemy objective with a little waving animated flag on top of it. When a tank reaches successfully that objective, a little swirl highlight shows to just kind of highlight that arrival. There's going to be a total of 3 scenarios. Each of the scenarios has a different map sheet. It has different types of paths associated with it. And as you can see here, there's not just one type of tank. There's actually 3 types of tanks, each of which have a different strength category, a different range category, things such as that, to add a little additional playability to the application. Let's take just a quick look at what we're going to do now in this tutorial to get build 2 completed. We're going to take the completed project and we're going to dissect it in a number of components. We're going to first focus on the enemy objective, look at its composition. We're going to look at the highlight associated with that when the enemy tank arrives. Then we're going to develop and take a look at each of the 3 collections for tank type number 1, tank type 2, tank type 3. And we'll look at the collection factories associated with each of those. Then we're going to take a look at the extensions that have been made to the controller script to accommodate the waypoint geometries and the spawning creation activity invoking those factories. Then we're going to take a look at the graphic user interface. We'll look at that GUI script file associated with the main menu, just to make sure that we've got the notifications, for example, for the next strike accommodated. And then the last step will be just a final build. Now, obviously, we've got a completed project here, but as we look at it, we just want to take a look at what that final piece looks like. So it is now time to actually get into Defold and dissect this project 2 build. I'm going to stay consistent with that tutorial structure we described here in the first video, where we're going to have a completed build 2 here, and we're going to deep dive into everything that's different. What have we added to what we finished with here in build 1? So here on the screen, you can see the total build. Let's go ahead and walk through each of the elements here in the assets window. I'm going to start with fonts. These are exactly the same fonts we used in build 1, so no changes there. Again, in modules, animation functions and the frames per second utility, again, no changes from anything we had in build number 1. Now, as we look at the script file, we're going to see that there have been some changes from how we ended in build number 1. There are 3 brand new script files. There's the enemy highlight script file, enemy tank actions, and treadmark actions, all unique to adding tank objects now to the game. We're going to review each of those 3 new script files here in detail in just a moment. Additionally, if you do a quick compare, you're going to see that there have been changes made to the controller script, as well as some changes made to the MainMenu.gui script, and we're going to dive into those, and so you can see exactly what changes have been made there. I guess the good news is there are 2 script files that have stayed the same, haven't made any changes at all. Have not made any changes to the map sheet, as well as the pop-up window GUI script. The images in our TD images folder are exactly the same. There have been no changes made to that. There's also been no changes made to any of the atlases, the 6 atlases we created in build 1. So what are the new components? You can see that we have an enemy highlight prototype. That's a game object. We have 3 new collections, a tank 1 parent, a tank 2 parent, a tank 3 parent, and lastly, we have a tread prototype game object. Let's go ahead and open up the main collection just to kind of, again, we're kind of doing a table of contents here to see what's the same and what's different. We have 7 new game objects in the main collection. We have the create enemy highlight. That's going to contain a factory. We have the create tank 1 collection, which is a collection factory. Create tank 2 and create tank 3 collections are the same. They're also collection factories. We have a create tread marks game object. That's a container for a factory. We have the enemy objective game object, which has as a component a collision object and a sprite. And then lastly, in terms of new game objects within the main collection, we have an enemy objective flag, which has a sprite component. So as you can see, we have our work cut out for us. I've annotated each of these incremental changes, and let's go ahead and jump in now and hit each of those modifications. Okay, this first segment is really straightforward. It's all the actions that we're going to walk through associated with the enemy objective. First, we'll walk through the actual game object itself for the enemy objective. That includes that building image that's embedded within a sprite. Then we're going to take a look at the enemy objective flag and the animation group associated with that. The third thing we'll do is we're going to have a prototype game object that will reflect the enemy highlighting, that rotating swirl that you saw here in the demonstration. And then we'll take a look at the container game object and the factory that's used to actually allow us to spawn that, that swirl, if you will. And then take a quick walkthrough of the Lewis script associated with that actually performs that swirling animation based on a rotation, and then also a timer that deletes the game object after a couple of seconds. Let's go ahead and start by adding an enemy objective game object to the project. That's our first goal here. I've temporarily pruned the game objects from within the main collection, as you see here on the screen, just to show the create enemy objective, the enemy objective, and the enemy objective flag game objects. It gives you a little better view of them in the editor view window here in the middle. Let's start first with the enemy objective. It's located at least here at 512.325, but that's really just notional. We're going to set that location dynamically within our code depending upon which scenario, which game level we're actually playing. Notice here, importantly, the z-index is a 0.8. That's going to place this enemy objective on top of the map screen at the very top. You can also see that we have 2 components associated with the enemy objective. The first is the collision component. I've used this in order to determine when an enemy tank actually arrives at the objective destination. So that'll be the trigger. So it's going to be a trigger type collision object. As a trigger type, I'm going to register very simple collisions, and note that the group is set to enemy objective and the mask is set to tank body and also bullet. That'll filter the collisions that are registered and processed by our script files. A box shape is associated with this collision object, And as you can see, it's sized as 100 by 100. And so basically fits right on top of the building sprite that we see here. The sprite references the graphic assets atlas as the source of the image, and the image is building. Now let's go ahead and take a look at the enemy objective flag. During the initial demonstration of the build, we saw the flag waving on the roof of the objective building. That's really the purpose of this game object. I know, a little game pizzazz. So with the enemy objective flag in focus, we can see that we've set it at 512,400. But just like we did with the enemy objective, we're going to reset that in our code depending upon which scenario is being played. Notice here also that I've set the Z index to 0.4. That's going to place this flag above the map sheet, but it's going to be below the enemy objective game object. So that's right where we want it. So we're going to have a map at the bottom, a waving flag, and then a building on top of that. This is pretty simple. I've got a sprite as a sprite component associated with the enemy objective flag game object. That image for the sprite is sourced out of our map assets atlas, and we're going to use the objective flag animation group. It's going to be an animation group to affect that waving action. Okay, now let's go ahead and take a look at the enemy highlight. Now, the last game object is going to be related to a spiraling image that's going to occur on top of this objective every time an enemy tank, successfully reaches the objective. And that's going to be done by creating a game object prototype that reflects that image and the animation that we want for the image, and then a factory that can be called to spawn that game object from within our code. Let's go ahead and walk through it. We have an enemy highlight prototype. Now you can see that swirl that I'm talking about that's going to show every time an enemy tank successfully hits the objective. The prototype really consists of two components. It's got the sprite. The sprite's located at 00 AK. It's going to be centered right where the game object is located. And it references the graphic assets atlas as the source of the objective highlight image. Now let's look at the component script file for this prototype. Well, here's our enemy highlight script. We have our standard header obviously on the top. But as you see, all the functionality in this script is located within the init function, that initialization function. That is, when the game object is spawned by the factory, it's going to call the init function and do several things. First, it's going to set the Euler angle on the z-axis to 0. And then it's going to initiate a full 360-degree rotation animation around that z-axis and put that on a playback loop. Then it's going to initiate a timer delay of 2 seconds, upon which the game object is going to be deleted. So what does that do? That provides us basically a 2-second spiral animation and then deletes the game object at its completion to conserve memory. Well, now that our enemy highlight prototype is complete, let's go ahead back to the main collection. As we see here, the main collection has a game object entitled Create Enemy Highlight. That game object contains a factory component. And if we open up that factory, we bring it into focus, we see that the factory is linked to the enemy highlight prototype that we've just walked through. Okay, I think you're going to find that this segment's a lot more intensive than the previous segment. We're going to focus on our enemy tanks, and we're going to use a collection for each of those 3 tank types, 3 distinct collections. And the reason we want that is we want a body that's distinct from a turret, so the body can rotate one way, the turret can rotate another way, and obviously need to worry about collision objects, both for range and for collision hits with bullets, and a number of other features like the strength indicator underneath the tank. We're going to have a container game object that's going to actually have the collection factory as a component to that, and we'll use that for spawning tanks. We're going to have a tread animation, so you can see that tread, there'll be a game object with a fading animation group behind it to show the path. And last, and probably the area that we're going to spend the most time on, is the actual enemy tank actions Lewis script. It's a fairly lengthy script, and in terms how we initiate the geometries associated with the tank paths. And we're going to do a deep dive into those geometries, especially those associated with rotating the body so that it's in line with the path segment that it's on, as well as rotating the turret so it's always pointing at the end enemy objective. And we'll be introducing the concept of quaternions, which is really the geometric metric that Defold uses. I think you're going to find that very helpful because that's a common requirement in many, many games that we develop. Let's start delving into our tank objects by starting first with the prototype collection associated with Tank 1. If we bring the Tank 1 parent collection into focus, you can see here in the outline window, we have a collection that has a parent game object, Tank. And if we look at the tank, we can see that it's located at 0, 0, which we're going to change, obviously, as the tank moves around the game, but it sets the Z index associated with a 0.4. That's going to place it above the map sheet, but below the enemy objective game object that we just reviewed here earlier. If we open up the tank parent, we can see that it consists of 7 components. One at a time, let's deep dive into each of these components. Let's start with the tank body. The tank body is centered on the parent tank. It's 0, 0 is relative to that parent, the tank. The Z index is set to 0.2. And this also serves as a container for a sprite. That sprite is sourced out of the Graphic Assets Atlas, and the image is Tank Body 1. In addition to the tank body, we also have a game object for the tank turret. The tank turret is also centered on the parent tank with a Z index of 0.3, aka it sets it right on top of the tank body. Does have, if we open it up, does have a sprite component, and that sprite component is the image Tank Turret 1 that's resourced from the Graphic Assets Atlas. Now let's look at the Strength Indicator game object. That's this set of bars right here at the bottom of the tank image, and we're going to be using that to show the player the relative strength of this tank as it changes over time as it engages defending towers. This game object is located at -2, -3 relative to the parent tank, and it's got an index of 0.2. The strength indicator also has a sprite component. In this case, we've set it to unit strength 3, which is resourced out of the Graphic Assets Atlas. But please note that the unit strength 3 is a single image animation group within that atlas. And that's going to allow us to dynamically change the strength animation group within our code, depending upon what's actually happening to this tank as the game progresses. I've left in some of the components I use associated with debugging. You've probably seen that as we've gone through this. I've included a label on top of the tank. I've located it at X of 0 and Y of 35. I'm going to use that as a means to monitor the tank properties during debugging. It's a really handy aid, and it's easily turned off by setting the label to a blank. The tank parent has 2 collision objects. The first is associated with the firing range that this tank type can use to engage other targets. And the second is the tank itself as it relates to incoming fires hitting the tank and having a collision when that bullet physically hits the tank. Let's first start with the range collection object. How far away can this tank engage a tower? That's what this collision object is really used for. It uses a trigger collision type as the means for messaging the tank game object that a tower is, quote, within range. Note that the group is tank range and the mask is tower body, so only that tank range and tower body relationship will be triggered. For this, we're using a sphere shape for the collision object with a 300 pixel diameter. Secondly, we have a tank collision object. This is used to determine if the tank has received a hit from a bullet that's been fired at it by one of the towers. The collision object here is a kinematic type collision, and that monitors 3 types of collisions using the masks that we see. First is a tank body colliding with the enemy objective. That initiates a success with resource gains and things such as that. Secondly, the tank body can collide with a bullet. That'll result in a loss to its strength. And thirdly, the tank body can collide with the tower range, resulting in the tower engaging the tank. So now that the Tank 1 collection is complete, here's what it looks like. Now I've got some good news. Tank 2 and Tank 3 are structured exactly the same way. If I open up the Tank 2 parent collection, you can see that the structure of the Tank 2 collection is exactly the same. And also, you can see that the Tank 3 parent collection is exactly the same. The only difference between the Tank 1, the Tank 2, and the Tank 3 parent collections are the nature of the sprite associated with the body and the sprite associated with the turret, and the size of the collision object spheres for both the range and the physical tank. Well, now that we've seen all three tank game object prototypes, let's go back to our main collection. We have three game objects that contain collection factories. We have the Create Tank 1 collection, where the Tank 1 parent collection is identified as the prototype within the property window. We have the Create Tank 2 collection, and it also has a component, a collection factory, with Tank 2 parent collection as the prototype. Lastly, we have a Create Tank 3 collection, which is a container for a collection factory as well, where the Tank 3 parent collection is the prototype. You may have noticed that these tank prototypes all have a script file as a component. We're going to go through that script file in some detail here very shortly, but first, I'd like to review how the tank tread marks are created first. I thought it'd be interesting to add some tread tracks behind each of these moving tanks. Kind of a nice aesthetic feature to add to the game. Let's take a general look at how we do that. The general approach is going to be to have a prototype game object that reflects one tread mark. And then we're going to spawn them behind the traveling tank on a timer, and they're going to have an animation group that fades them out after a certain short period of time. So let's see how that's accomplished in the project. We have the tread prototype game object within the project asset window, that's shown here. It consists of a sprite, the tread mark, and that contains the animation group tread fade, which is sourced out of the graphic assets atlas. The tread prototype also contains a script file, tread mark action. Let's go ahead and walk through that script file. It's pretty straightforward. When initialized within the init function, a message is posted to the tread mark to play the animation tread fade. And then when that animation is complete, it will send a message back indicating that the animation is done. And when that's received, we're going to go ahead and delete the game object. Having completed our walkthrough of the tread prototype, we can now see how its factory has been added to the main collection using the Create Tread Marks game object as its container. As we begin looking at the script enemy tank actions, it's pretty clear. We've got a lot of territory to cover here, so hopefully taking the following approach is going to make it easier to understand. Let's first define a few terms that are going to be used in both this enemy tank action script as well as in the extensions we're going to apply to the controller script. And then second, when we get to the code, we'll keep a running code structure table on the left-hand side of the screen, and we'll keep the script on the right-hand side of the screen. Terminology, pretty important. Let's go through these definition of terms. Level. The game is going to consist of multiple scenarios, which we're also going to call levels. And as we discussed in Tutorial 1, you select the level you want to play within the initial opening main menu. The global variable num levels, number of levels, is a constant reflecting the number of game levels the application is built for. Now, please note that by using a variable constant, I've made it so that you can more easily add new levels to the game at a later time without major code rewrites. Strike. Each level consists of multiple strikes. A strike is a series of tanks proceeding along a designated path towards the objective. The first strike is going to be conducted by enemy Tank 1 type units along Path 1. And then the second strike is going to be by the enemy tank 2 units, the third strike by tank 3 units, and the fourth strike is going to be conducted on randomly selected tank types, advancing along randomly selected paths. The global variable num strikes, number of strikes, is a constant that designates how many strikes there are per level. Waypoints. An enemy tank is spawned at waypoint number 1, and then it moves from that waypoint to the next waypoint to the next waypoint along a path. And the coordinates of that path are contained in the two tables, x coordinates in the x path and y coordinates in the y path. And let's take x path as an example. It's multidimensional, and as shown here, the indices are level, then strike, and then waypoint. And the y path is structured exactly the same way. Now the variable waypoint 1 designates the beginning of the path segment that the tank is presently traveling on, and waypoint 2 is the end of that path segment. To accommodate some minimus error, the close enough variable designates the radius of a circle around waypoint number 2, which when entered designates that the path segment is deemed complete. Hey, now that we've completed that short primer into some of the terms used within the game, let's go ahead and apply those terms to the game logic within the enemy tank actions script. First, as normal, there's a standard header comment on the top of our script file that identifies the project and the script file name, and it also summarizes the key features that are going to be supported by this specific script. That's immediately followed by several declarations. The first set of declarations are associated with our local variables, as well as our script properties. The first local variable we're going to declare is max waypoints. That's actually the maximum number of waypoints, individual waypoints, that you can find in any of the paths on any of the scenarios that the tanks are going to follow. This project uses several tables to store the coordinates for each of those waypoints along the path, from the beginning, where they're spawned, all the way to the objective. The first table is x path. That's the x coordinate of the waypoints, and it has 3 indices. The z is the level 1, level 2, or level 3, since the paths are going to be different for each of the 3 scenarios of gameplay. The I is the strike 1, strike 2, or strike 3. Each of those strikes has a different path for getting to the objective. And J is the waypoint. Waypoint 1 is the beginning of a path leg, and waypoint 2 is the end of the path leg. The Y path is structured exactly the same way and provides the Y coordinate for each waypoint. The num waypoints is a table that captures the number of waypoints that are actually populated. Although they can have up to 20, each individual path will have a different number of waypoints. We need to capture that. Once the tables are established, the code initializes the X path, the Y path, and the number of waypoints according to their geometric values. We do that for level 1, level 2, and level 3. Next, we're going to declare some script properties, remembering that script properties are going to be unique to each instance. For each individual tank that's spawned, it'll have its own unique script properties, because we don't want the location of one tank to bleed over and become, therefore, the location of every other tank. So I'm going to try to stay consistent. I'm going to place a short definition beside each of these variables as they're declared within the script, as you can see here on the right-hand side. The waypoints keep track on which leg of the path the tank is presently on. Waypoint 1 at the beginning of each leg, waypoint 2 at the end of the leg, with close indicating that it's close enough to waypoint 2 to go ahead and start that next leg. When a new tank is spawned, there's several properties that are passed. Active path, that's the path that's currently being traversed. The type, there's 3 types of tanks, which type is it? And the strength, what is the actual combat strength of that particular tank? For at least this build, I've also included a counter. That's not going to really be used in the game, but I found it pretty useful as I'm developing this, and you may as well, as you look and dive into this, keep track of which tank has been spawned where. And the last three script properties include 1. Tread scale. That's the scaling factor that's going to be applied to each of the tread mark objects. They're going to be spawned in order to trail behind the tank while it's moving along the path. The next is the tread delay, and that's the actual delay in seconds between each of those spawned tread mark objects. And lastly, but hardly least, is the turret angle. That's the actual angle that's going to be measured in radians that the turret needs to be rotated to in order to point at the objective. I identify a parameter table, props, and I'm going to be using that to basically as a receptacle to pass the parameters into the factory that spawns the individual tank. And lastly, I've got a local variable, objective, that's going to store the address of the final objective for that tank. Next, we have a local function, point toward objective. For this tower defense project, if the script property self-target equals the enemy objective, we want to rotate the tank turret so that it's pointing towards the target that's either within range or is actually being fired on. And we'll address other types of targets in one of the later builds. Before we examine the Lua code too closely, let's go ahead and stop. Let's do a deep dive and take a closer look at how Defold handles angles, and in particular how it uses radians and quaternions. I know, quaternions, a real household term, isn't it? Okay, let's jump in. I hate to do this, but game design requires a little geometry, a little trigonometry. So we're not going to get too deep into the weeds here, but let me just real quickly give you the real highlights, just very high level, of some trigonometry concepts that you really need in order to understand basically rotation. The use of how to rotate your game objects around using the default engine. And all game engines require basically the same thing. The first thing to understand is it doesn't really use angles and degrees like we would all might be used to. It uses radians. So what's a radian? Well, if you took the radius of a circle and you wrapped it, you took a point on the circle and you kind of wrapped it around the circle, one radius on that wrap would equal 1 radian. And that equals approximately 57.3 degrees. So that's basically that mechanism. So let's go ahead and take just a couple quick examples here. Here's a tank at 0 degrees. Okay, no big surprises there. Tank at 45 degrees. And you can see the number of radians associated with each. 90. 135, 225. So you can kind of get a general sense from those diagrams, the difference between the degrees that we're used to and the number of radians that we would use in our game engine. So one of the things we're always interested in is I've got a point, let's say the location of a tank. I've got another point, let's say the location of that enemy, the tank's objective. And I want to figure out what rotation do I need to go to in order to have the tank pointing towards that objective. And in this case, we would use a math function, a Lua math function called arctangent, the arc of a tangent. And it would equal the objective position, the y-coordinate of the objective position, minus the y-coordinate of the tank position, divided by the object position x minus the tank, the x-coordinate of the tank position x. So if you take that difference between the objective and the tank at the y level, divide it by the difference between the objective and the tank and the x level, and take the arctangent of that, that'll tell you the number of radians that you need to rotate. So now that we have that and we can compute that angle in radians, let's convert that to some pseudocode. So as you can see here, we first compute. In order to do this, we have to compute that arctangent, which we do here with the math function atan2. Another crinkle. We have to convert radians now to quaternions. Quaternion is how it measures. Maybe you've got 3 dimensions here, right? You've got x, y, and z, up and down, if you will. So we need to convert that to quaternions. And so you see another math function here, quat rotation. And that allows us to convert the angle in radians to the angle in radians. And then from that, we can go to a game object set rotation, providing it the angle and quaternions, and that's what we would use to rotate our game object to point from its current location towards an objective. And you're going to see that same logic associated with the rotation of tanks, tank turrets. You're going to see that associated with our towers. You're going to see that associated with bullets. All of these have a different orientation on the screen depending upon what's taking place in terms of interactions between tanks and towers and the like. So I'd recommend kind of going through this sequence here maybe a couple of times. It can be a little bit confusing. If you look in the default documentation online, it provides you some pretty good walkthroughs of that. And this basically is at the highlights. Okay, hey, this segment is going to be exclusively associated with the controller script. We have some local variables we're going to declare, principally associated with how many different paths we have, how many tanks we have on each of the individual strikes, where the enemy objective is physically located on each of the map scenarios. We've got some new messages associated with starting strikes and deleting tank objects. An important aspect of this, and we'll have a deep dive unique to this, is game object management. We're going to be spawning a lot of tanks, but based on fire exchanges, we're going to be deleting some tanks. And the tanks consist, as we saw earlier, of a parent as well as a child set of subordinate game objects, and we want to make sure that we don't have a memory leakage. So we're going to talk about that a little bit. So let's go ahead and jump into the controller script. So as you all remember, we included an initial version of this controller script within build number 1. Let's just take a moment to see what changes have been made in the aggregate to what we did earlier, as we now extend the functionality of this controller script to accommodate the creation of enemy tank collections. You know, I use a utility called diffnow, www.diffnow.com, as a really convenient and handy tool for the comparing of files, in this case script files. For these tutorials where the script files have been changed, I thought that before we jump straight into the syntax, it might be a good idea to highlight the major areas of change first using the diffnow tool. So let's go ahead and do that. First, we see that the comment header has been revised to reflect the new functionality. 2 new global variables are included that reflect the tank status as well as the current location of the objective. You know, there's a whole series of new local variables being declared. They focus on tank parameters. We're going to address each of those in detail shortly as we conduct the detailed code walkthrough. There's 2 new local functions being added: delete tank entries and start next strike. And the function start selected level has been extended to process the end of level banner. Another new local function has been added, end active level. 3 new global functions are included: tank active, round, and table find. There's a new message posting statement within init that disables the enemy objective. That would be done during initial splash screens. A change has been made in the text displaying during the opening pop-up to identify build 2 features. And several new messages are included within an onMessage function, which manages the end of level process, as well as when the tank reaches the objective. And finally, the update function has been moved to the end of the source code. Well, that certainly set the stage. Now it's time for going beyond a quick what's changed diffnow summary and actually deep dive into the syntax for our new build 2 controller script. I hope this works for you, but I don't think it makes sense to go through each and every line of code at this point. Rather, I think it's important to just focus on those Lua code entries that are absolutely new for this build number 2. As you can see, our header comments have been revised to reflect the new functionality for build 2. And a global flag variable is declared for the initial setting of deleted, as well as the current objective being initially set basically to a stub, a vector 3 of 0, 0, 0. As you can see, we've added several new local variables. These are primarily characteristics associated with the tank entities that will be created within the build. Definitions for each of these are highlighted within the comments as you see here. The number of active towers, and a table of tower types, a table num tanks, how many tanks are spawned for each strike by level, with the time between those spawnings equating to time between tanks. The location and vector3 format of the objective associated with each of the 3 levels, each of the scenarios. A matrix of possible path designations for each level, where the path chosen for strike 4 in each scenario is randomly chosen from those options. Spawned tank objects. This is a table that contains the IDs of all active, aka spawned and not deleted, tank collections. Props. This is a table that's going to be used for passing properties within our messages. Tank spawned counter. That's the total number of tanks that have been spawned, and the tank destroyed counter, obviously, number of tanks that have been destroyed. Both of those aren't in the final game, but very important here during a debugging phase. We do declare a time, which will be used in spawning tanks over the timeline. And finally, we declare several script properties defined on the right. The current strike, a status flag related to the end of the level, and a status flag related to the end of a strike. You can see that this extension to our Controller.script provides several new local functions. Delete tank entries. This deletes all the entries within the spawn tank objects table to include tank, strength indicator, tank body, and tank turret. This function essentially clears out all the IDs for tanks previously spawned. I could admit that this deep dive is the end result of a lot of mistakes I've made along the way. So as you have game objects and you have factories or collections and collection factories, and you start to spawn collections or spawn game objects and then delete them, if you're not really careful, you start storing deleted game objects, and you thought you deleted them, but you haven't. Start accumulating up in memory, and you can have a challenge with memory. It's called memory loss. So the first rule to remember in Defold is that, let's take our tank collection. We have the tank as a parent, and then we have 3 subordinate child, if you will, game objects. We have the tank body, we have the tank turret, and we've got the strength indicator. That collection exists as you're building and developing your game. But when you build it and then compile it, the concept of a collection goes away. They're just individual game objects out there. So if you want to delete them, you can't just delete the parent. You have to delete the parent, and you also have to explicitly delete each of the child IDs. So what does that mean in terms of our design? Well, it means that number one, when I spawn a new tank collection, I've got to capture the IDs for all of the components. So I have to capture the ID for the tank parent, and I have to capture the tank body ID, the turret ID, and the strength indicator ID. And when I delete them, exactly the same thing applies. When I go to delete it, I have to delete both the parent and all the child IDs. And so that's where I have a spawn tank objects table that I capture all those IDs when I do my create, my spawning, and I delete all of them in my local function for deleting tank objects. Start next strike. This controls the processes related to starting a new tank strike, to include establishing Lua tables for the tank type, tank strength for each of the 3 tank types, setup of the characteristics for each of the enemy tanks to be spawned, principally focused on tank type and tank path. We initialize the 2 counters used during debugging. The tank type and tank path tables are initialized with the type of tank for each strike, as well as the path to be followed for that strike. Notice that during the 4th strike, it's slightly different. The type of the tank and the specific path to be followed are actually randomly selected from the set of all available types and all available paths. Then, after posting a notice to the player, a timer is set for each of the num tanks associated with the active level, which updates the counter, sets up the props table with the characteristics to be passed to the collection factory, and calls collection.create for the appropriate collection factory for this tank type. Note that each tank type has its own collection factory. For example, there's a create tank 1 collection, a tank 2 collection, and a create tank 3 collection. A flag is then set to reflect that the next strike processing is complete. This prevents other actions within the game being conducted while this function is still underway. The next local function is the start selected level function. It's a utility function that sets the current strike to 1, it resets the end banner indicator, it enables the game map for this particular scenario if the level selection panel was bypassed. It also initializes the enemy objective for the level. Specifically, it enables the enemy objective, setting the global variable current objective, and setting the positions using the go set position function for the objective, in this build the building, and the flag, the enemy objective flag that's superimposed on that building. On a delay timer, it initiates the next strike by calling start next strike after a setup delay, which is in this case 5 seconds. A new function, end active level, is now declared. This function conducts overall cleanup at the end of each game level. Specifically, it cancels all the active timers. It stops any planned actions such as new tank spawnings. It removes any remaining tanks still active on the game map. Then it sends a message to the main menu that indicates please show it the main menu, the one where you get to select the next level. For build 2, we've added 3 new global functions. Tank active, which returns true if the tank URL is still viable, aka the ID is still retained within the spawn tank objects table. Round, which returns a number with a specified number of significant digits, aka decimal places. And table find, which finds the index within a Lua table for the element value provided. The changes in build 2 for the initialization init function are that messages are now sent to direct the disabling of the enemy objective and the enemy object flag, and that's until the splash screen sequence is complete. Several new message IDs are processed within the onMessage function. The first is enemy reached objective. This initiates the spawning of the enemy highlight game object. That's that rotating object that you see when the tank enters the objective. Lasts for a couple seconds and then it's self-deleted. The next message ID is delete tank collection. This is an important segment, all really part of our memory management best practices. There's going to be 3 major actions accomplished in the removal of a tank collection from the game. First, its ID is contained within the message ID that was passed into the controller by one of the other scripts. The first thing we're going to do is we're going to increment the tank destroyed counter. And then the spawn tank objects table is going to be searched for the hash of /tank that equates to the message ID that was passed to the controller. That entry is going to be deleted from the spawn tank object table. But then the actual game objects for /tank, /strength indicator, /tank body, /tank turret are all going to be deleted from memory using the go.delete function. Lastly, it's determined whether or not this is the last tank within the current strike. If it is, then the processing end of strike and the processing end of level flags are going to be set to false, and the current strike indicator is going to be incremented to the next strike, unless we've just completed the last strike in that particular level. If it is the last strike, start next strike is going to be called, that function, after an 8-second delay. That delay allows us appropriate time for the game to produce an end level notice to the player so the player knows exactly what's taking place. Another new message ID is end level banner complete. What this accomplishes is once the end level banner to the player is completed, the controller calls the end active level function. So it's basically a switch that doesn't start ending the level until the banner is completed. And the last message is the hide all Defold collision objects. When that's received, the controller sends out a message to every spawned defensive position game object, directing it to hide its collision object. In other words, it deactivates the defensive positions. And that's for future builds. Okay, we're getting down to the wire now. Segment number 4. We're going to focus on the graphic user interface. We've made a couple quick changes here. I've made a couple quick changes. The first is I've got each of the scenarios in the level selection panel available. We've unlocked them. The reason for that is so that here during this detailed walkthrough, you'll have the opportunity to go to any of the 3 scenarios and pick to make sure all the logic works appropriately for whichever level you happen to be on. There's 2 additional messages that we need our GUI script to be able to accommodate. The first is the display of a notification that there's another strike coming to prepare that that strike is on its way. And the last one is a banner that either tells you whether you were successful on this level or you were defeated in this level. So let's go ahead and jump into the GUI and take a look at how we've accommodated these changes. Well, to complete the Build 2 project, there are a few extensions that have been made to the MainMenu.gui script. So let's go ahead and use our Diff Now website tool to take a look at each of those. There are now 2 new local functions, Fade In Banner and Fade Out Banner. The level status flag is set to true. That enables a selection of any of the possible scenarios or levels. Again, you would normally not do that in a game. You'd want to complete level 1 before 2 and complete level 2 before 3. But just for getting familiar with the game, I've set them all to true so you can pick and choose any of the possible scenarios and play through that without completing the prior one. And then there are several new messages that are being processed within the onMessage function to include display next strike coming and end level. Well, now that we have some perspective, let's go ahead and dive into the syntax and walk through in detail each of the changes to script. This is going to be our last script walkthrough for build number 2, so here we go. Pretty simplistically, there are 2 new local functions that support the display of a level complete banner at the end of each level, aka every time we complete one of the scenarios. The first is by calling the Fade In banner, which, number 1, enables the banner. Then it sets the from and the to parameters prior to using GUI.animate to transition from a fully transparent to a fully opaque set of images. Then have the complete function go to Fade Out banner, which is called as soon as the first animation is completed. The Fade Out banner uses very similar logic, but in reverse, fading from opaque to transparent. It also has a callback function, which sends the end of level banner complete message back to the controller. Within the init function, the self.levelStatusScript property table has 3 entries, 1 for each scenario. If true, the player can select that level from the menu. If false, the level's locked. As I mentioned just a little bit ago, I thought it would be helpful to set all 3 of these to true for this particular build, so we can select any of the scenarios from the main menu just to simplify overall debugging. For this build, there's several new message IDs that will be processed within onMessage. Here they are. The first is display next strike coming. Every good tower defense game has a short blurb that tells you when the next set of tanks is going to be entering the screen. And that's the role that this message plays. We accomplish it as follows. First, the self.notice node is enabled. And then the GUI.playFlipbook function is called, setting the notice node to the standby notice graphic. Then the fade in function is called. And following that logic, the fade-in function brings the graphic to full opaque, then calls the fade-out function to fade it back down to transparent. And upon completion, the node's disabled. There's an end level message. When MainMenu.gui receives this message, it displays the end of level victory and/or defeat banner. It does so by, quote, enabling the self.level banner. It uses the GUI.flip playbook to set the appropriate graphic, and for now we're going to use the red victory banner. In tutorial number 5, we'll be addressing scoring, and with that we can set the banner to either a victory or defeat. The active level is updated to open up the next possible scenario, but it can't exceed the number of levels, and then it will set the status for that next possible level to true. And then finally we call the fade-in banner we just walked through to display it. Okay, at this point, build 2, we've pretty much walked through all the various components associated with it. So I think it's a good time, if you haven't downloaded it yet, go ahead and bring it up in Defold and hit build and take a look at it in detail. But I'm going to just do a real quick walkthrough right now, just so you can see from a user or a player's perspective what we've accomplished in the various components and the various logic within our code that we've walked through so far here in Build 2. Okay, I'm just doing a really quick run through here just to hit the highlights of what we've accomplished here in the features of Build 2. I've turned off the splash screens, cut down a little time. I've unlocked each of the levels so that we have the opportunity to go to whichever level that we'd like. We do have our debug messaging on. Obviously, you'd turn that off for a full release version. I've got 3 options available. I'm going to go to crossing the desert, just option 1. You can see we do have our pop-up screen. In this case, I'm identifying the version 2 features, but obviously this would be where you'd provide some help or user instructions or game rules, if you will, to the players that you're targeting. We do have our objective here with our waving flag. We've got now a strike of, in this case, tank type 1. We have a strength bar underneath the tank icon. For debugging purposes, I've put the numeric strength on top of that. We're going to use that here as we get into our fire exchanges, just to make sure that the logic is working the way that we want it to. I do have a notification for the end of a strike, telling you that the next strike is getting ready to launch. Now I've got my second strike. I've got a different tank type. In this case, it's a tank type number 2. It's a little stronger at 150 points. I've kind of bounded this to two tanks per strike, just to simplify this here a little bit. When it gets to the objective, you can see I've got a little swirl, just to highlight the fact that an enemy tank has successfully arrived at its objective. I get another standby notice, and now we'll have strike number 3. Again, a different tank type, in this case, tank type number 3. A total of 200 strength points, a lot more strength bars underneath it to indicate that. Gives you an idea of the relative strengths between the two. And now I've got my fourth strike. The fourth strike is a randomization. I randomized the tank type, I randomized the path, and again, I only have 2 here, so you're not really seeing that variability, but it kind of gives a little less predictability to the user, increasing overall game playability. At the end of the scenario, I get an end of level, in this case, victory banner. In another case, it would be a defeat banner. I've got the 2 other scenarios work exactly the same way. As you see here, I've got the river breach. River breach scenario has a different map sheet. The paths, the waypoints, the geometries are all different, as we saw in our code, but the tank types and the tank strength are exactly the same. And if I go to the third scenario, the embankment, as you can see, I have a different map sheet, a different location for my objective. Again, I have my paths and the waypoints will be different to reflect the demographics, if you will, or the topography, associated with this map sheet. I start with tank type 1, and all the same functionality applies in terms of the tread marks, the turret continuing to point at the enemy objective, tank 1 type at the path 1, tank 2 type, as we're going to see here now, showing up after the notification, showing up on path 2. And so the logic remains the same for each. I think you understand this is generally the focus of the second build. Okay, that brings build number 2 to a close. I really hope you've found it helpful. I've got this new approach for the tutorials. I think it's helpful. I think it's a little easier, I think, to digest, starting with a completed build and then taking a look at each of the assets, all of the objects that are generated, the component and component files associated with those objects, and spending a little bit of time on making a deeper understanding of what's going on in the script files, the GUI script files. So I'd appreciate your comments on that. That would be really helpful to understand if this is being successful for you as you're learning Defold and applying it to something in this size and scale. If you haven't yet, I'd certainly appreciate you being a subscriber. It means a lot. And it also hopefully gives you a means of getting notified as new videos are going to be published. I've got several more up my sleeve here as this tower defense series ends up. Our next tutorial number 3, we're going to now add towers to the mix. The ability to drag and drop towers that you as the player are in control of to various defensive positions across the entire map sheet, across, again, all 3 scenarios. Looking forward to seeing you then. Take care now.